Hi there! This video series is to display my problem-solving and learning abilities. I hope to show that I can solve any programming problem, regardless of whether I already have expertise in the language at hand. I hope this helps others in my field to learn not just how to solve a particular problem, but how to teach themselves a solution to an unfamiliar problem. For now, I am learning Python. I have no professional experience or formal training in the language, and have only been learning it since mid-January. While I'm picking up fairly quickly, I cannot claim any real expertise. Today, I am going to show my approach to solving the second Project Euler problem. Full disclosure, as you can see here, I have already solved it, but it's been long enough that hopefully this will help to display my thinking. I will link to both Project Euler and my repository in the description. Let's dive in. So, even Fibonacci numbers problem 2. Each new term in the Fibonacci sequence is generated by adding the previous two terms. By starting with 1 and 2, the first 10 terms will be blah blah blah. By considering the terms in the Fibonacci sequence whose values do not exceed 4 million, find the sum of the even-valued terms. So here is our actual problem statement, and let's go ahead and get going. Let's see. So first, here's a problem, and because I have already solved it, I do know this is the answer, so I'm going to copy that over as well so we can more easily check. Let's start with rather a naive solution here. So we have this limit of 4 million. We're looking for a sum, which will start at the number 2. And we have our first number is 1, and our second number is 2. And say while b is less than this limit. I made the limit variable and then forgot to use it. Then we want to find a c, which is a plus b. We want to check whether c is even, so if c mod 2 equals 0, then sum plus equals c. That way we're making sure only the even numbers are getting added to the sum here. And then a equals b, and b equals c, so that we can start over and do the whole thing again. And let's print out our results so we can see here. That's the 4613732. It's the same as the correct answer. So obviously this was a fairly small, quick running program, even though it has a rather naive approach. Let's try to make it just slightly more efficient, just for the sake of the exercise. So if we think about this 1, 2, 3, our sequence is 1, 2, 3, 5, 8, 13, 21, doing math in my head, 34, etc., etc. And we can kind of start to see this pattern, which is mathematically obvious, of every third number is even. So we can kind of cheat here, and we can say a is 3, and b is 5, and then cut out this if check. So we know that c will always be even, because it is a plus b, and then we want to set a to b plus c, I think. and then b to yeah, a plus c. So let's throw some print lines just for the sake of the debugging, and let's change the limit down to like 40, just so that we aren't running a million. I'm actually going to comment this, and then that way I don't have to count my zeros more than once. Okay, so this is only going to run, what, like 2 times. So we're going to print, let's do an F string. C is C. And then we want to say A is A. And what we're wanting to see here is B is B. We want, in the first round, right, when we're coming in with the 3 and the 5, sum is already at 2. We want C is going to be 8. So we want to add that to the sum. Sum will then be 10. And then we want to put A to 13, which is 5 plus 8. And then we want B to be 21, which is going to be A plus C. And then when we come in the second time, C will be 34. Let's prove it out by running it. Okay, so we can see our beautiful little 8, 13, 21, 34, 55, 89. Total is 44, which is obviously not right for the 4 million limit, but we proved that our little algorithm is functional, and it is because we don't have this check, just the slightest bit faster. Let's prove that it does work with the full total. There we go. And there are ways, I'm sure, to make this more efficient yet, but the rule with Project Euler is your solution prints out in under a minute, which obviously we are there. So I'm going to leave that as an exercise. And I'll catch you in the next one.